Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. Okay, now children, how are you? Is everyone okay? Is everyone in the best of their health? Okay, today we are going to study the addition of binary numbers. By the way, are we aware of the term of the process of addition? We have done it. Definitely, we have been doing it since our childhood. But what we do is we are aware of addition of binary numbers. So before I move on to this topic, let's talk about a very quick recap of how we perform the binary addition. Binary means the numbers that we are aware of, and these are all the binary numbers which humans comprehend, and the addition rules. If you can very quickly recap. Now, an example: if, for example, you are asked to add 7 and 9, these are the two binary numbers, and you are asked to add them. So definitely, what will be the result? 9 plus 7, 16, correct. What you do is normally you write down 6 below. As you can see, 57 and 19. So here, just to make the concept clearer, I have taken the two digits which are on the units place, 7 and 9, added them. And what we get is we get 16. And in the 16, 6 is treated as your sum and 1 is your carried value. If you recall, this is the term that your teachers used to use also in your math classes. So here, 6 is your sum value and 1 is your carried value. Then what you do is now you are going to add 1 and 5 and 1, and that gives you 7. And it means that your answer will be 76. So just remember the key concept that what we are doing is we are talking about like in this way, since it is two digits only, that is why the answer has finished. If assume you had the third digit, hundreds place, so we'll keep on adding till no other addition is possible, isn't it? Now, another example, if for example, you have on the units place or maybe any place, you have three digits. Like in this case, you have 7 and 9 and 8. So very quickly, if you do it, what is the result? 9 and 8 is 17. 17 and 7 is 24, correct. So what you do is you write down some value is your 4. As you can see here, 17 plus 29 plus 38, three numbers are there. And we have taken only the value that is present in the units place, which are 7, 9, and 8, added them, and what we received as the result of addition was 24, where we wrote 4 below and we carried the value 22 above. Like out of these 24, 4 was written as the answer and 2 was carried. And then the tens value was 2 plus 1 is 3, 3 plus 2 is 5, and 5 plus 3 is 8, and then you got the answer as 84. Isn't it? Isn't this something that we already have done? So we have been doing this, but maybe some of us have never heard the term sum and carry. But when we talk about the computer addition, or when we talk about the binary addition, we are going to use a few terms which will be used quite often. So if you actually learn it from now onwards, that whatever is the result, it is actually broken, if it's broken down into two parts, one is treated as your sum value and second one is treated as your carry value. In some situations, maybe it is treated as C for carry and S for sum. So wherever it is being used, you need to remember and you need to work accordingly. Now, but I hope that we all are clear about the rules of binary addition. Now we are coming to the rules of binary addition. If I have the two values which are 0 and 1, and I'm asked to add, then what will be happening? First thing is, I am talking about addition of two binary numbers. Very simple example. Now again, carry and sum, C or S. So if I have two values and both of them are 0, so 0 plus 0 will be a 0, definitely. It means in this situation, both carry and sum will be a 0. On the contrary, first number is a 0 and second number is a 1. Maybe the first number which is at the top is a 0 and second number which is below is a 1. Then you have 1 as your sum and nothing is carried. Isn't it clear? Any questions regarding the 0 plus 1 situation? The third situation is you have 1 the first value and 0 as the second value, still you will get the same answer as you obtained earlier. Your carry will be 0 and your sum will be 1. Till now it's correct, isn't it? Yes. Now moving on to the fourth situation, 1 plus 1. By the way, 1 plus 1, who can think that why is it written as 1, 0? Is there anyone who can think that why it is written as 1, 0? Okay, that's very simple. If I talk about 1 plus 1, 1 plus 1 is actually in reality 2. But there is no 2 in binary because binary is only based on two values, two digits, which are 0 and 1. So what we did is we found the binary for 2. And if you recall, the binary for 2 is 1, 0. And that is why the same principle as we learned, we did right now, that if we got 24, so we wrote 4 as the sum and 2 was carried. So applying the same principle for 1 plus 1, it is actually 2 or 1, 0. We wrote 0 as the sum value and we carried the value 1. The way we actually carry the second value 1 to the next number. The same way as we did for 24, we wrote 4 below and we wrote 2 above the second tens position. Fine, it's the same principle, but just whenever you are doing such additions, keep track of the same principle, that if it's 2 or 3 or whatever, then you have to find the equivalent binary value and then you'll be able to figure it out. Any questions, any ambiguity? I'm repeating, 0 plus 0 is 0 for carry and 0 for sum. 0 plus 1 is 0 for carry and 1 for sum. 1 plus 0 is 0 for carry and 1 for sum. It's very simple till this point. But the example for the fourth point is also very simple. 1 plus 1 is actually 2. We found the binary value for 2, and that was 1, 0. In this case, we wrote sum as 0 and we carried 1 above. Clear? Will we move ahead? Now, once we are done with the addition of two binary numbers, let's see what happens if there are three binary numbers. Again, you can see I have three binary numbers. And in the first example, all the three numbers are zeros. 0 plus 0 plus 0. So definitely, in this case, carry will be 0 and sum will also be 0. Second situation, two numbers, two digits are zeros, and the third one is a 1. So in this case also, you will get carry as 0 and sum will be 1. Any questions? Okay. 0 plus 1 plus 0. Again, in this case, one value is a 1 and the other two are zeros, no matter where they are placed. So again, this answer is going to be same. Your carry will be 0 and your sum will be 1. Situation number 4, 0 plus 1 plus 1. Out of three binary numbers, one binary number is a 0 and the rest of the two are 1s. So again, you will recall the same principle as we have done just recently, that 1 plus 1 makes 2. You'll find out the binary for 2 and that makes it 1, 0. So here you will write down sum as 0 and you will carry 1. Clear? Then you have 1 plus 0 plus 0. That makes again the same situation. 1 is your sum and carry will be 0. Clear? Then you have the next situation, 1 plus 0 plus 1. Just think from the same perspective. There are two ones and the third one, the third digit is a 0. So you will apply the same principle. 1 plus 1 is going to be 2. We will find out the binary for 2 and we will get 1 and 0. 0 is will be your sum and 1 will be your carried value. Any questions? Any problem till now? And again, you can see wherever there are two ones, so you are applying the same principle as we have done just recently for the two binary numbers, that it will be resulting in the carry value to be 1 and the sum value will be a 0. And now lastly, we have three ones. So how to handle these three ones? 1 plus 1 plus 1. That's great. 1 plus 1 plus 1 will be 3. And when you find out the binary for 3, it will be 1, 1. And that is why the carry is 1 and the sum is also 1. Any questions, any ambiguity till now before we proceed to the example questions? Yes, Sharman, any problem? Okay, that's great. It means that we are now in a position to move ahead. First example, Just for the purpose of simplicity, I've taken a very simple example. You can see there are five values, five binary numbers for both of the digits. Now, what happens is 11101 10011. What we did is we first of all wrote the values one over the other, like 11101 above, and then 10011 below. Now, starting from the same position, remember the same principle as we have learned. So we will have, we are going to start from the right-hand side of what we say in math as the units place. So the same thing will be done here. The same principle will be followed here, that you're going to start from the rightmost bit, and the rightmost bits are 1 plus 1. Yes, exactly. So just recall 1 plus 1 is actually 2, or in reality it is going to be 0 with a carry of 1. So you can see here what we did is we first of all 1 plus 1 was resulting in a 0 and the carry of 1. Clear? Then this is my carry value. Either you write it here or you write in some below, and that they both are correct. But just for the purpose of something that we already do in math, I've taken this help also, so that we can create a link between our prior learning of dictionary handling and this learning. Now I'm working on the second bit, which is 1 plus 0 plus 1. So recall the same as we have learned. 1 plus 0 plus 1 means it will be 0 with a carry of 1. And then it will be 1 plus 1, 0 with a carry of 1. Then again, 1 plus 1 plus 0 will be 0 with a carry of 1. Any questions till now? Are we all clear about it? And then lastly, we got 1 plus 1 plus 1, 3 ones. And 3 ones means it will be 1 with a carry of 1. But since there is no carrying position left, that's why the last value 1 was written here. Any questions, any ambiguity, anything that is unclear? Again, very simple. We'll apply the same principle. For that, what we need to remember is we'll start from the right-hand side. First thing, the way we do it in normal addition. And secondly, we are going to recall, we are going to remember the rules of addition. And then we'll keep on adding and remember the carry values and the sum values, and then your answer will definitely be accurate in the first goal. Again, just a suggestion. If you think that you need to verify your answers, what you can do is, you can first of all convert the binary values into the equivalent denary numbers, and then add the two denary values, and what you obtain will be actually your final answer. That is perfectly possible. Clear, children? Any questions, any ambiguity regarding this topic? Now, another activity. Now you can see there are more bits. It's a complete byte. We have 001 00111 to be added with 01001010. You can see the same thing is done here. So in the beginning, the value is written here. Then you have written the second value below, and then you have added. Now, in this case, they have mentioned it separated so that you can comprehend this well. At column 1, this is your column 1, which is going to be starting from here, is 1 plus 0. So you will get the answer. 1 plus 0 will be 1 with no carries. That is why there is 1 and no carries here. Column 2 is now 1 plus 1. That will be 0 with a carry of 1. That is why you can see 0 is written here, and 1 is carried to the next bit, to the next value. You write down the carry values here, that's perfectly okay. There is no harm in writing down here, or the way you have been doing it in math, that is also possible. Now, it's okay. There is no worrying that where should I write down the answer. Now, for the third bit, you can see now it is 1 plus 1. So now 1 plus 1 will be 0 with a carry of 1. So 1 is carried here. For column number 3, we are done with, you can see 1 plus 0, and then previous value of the sum is also, carry is also mentioned here. So we get 1 plus 0 plus 1, that makes 0 with a carry of 1. Now we get for the fourth column, now we have for the fourth column 0 plus 1 plus 1. So again, the same principle that you have learned recently, you will apply, and what you obtain is 0 with a carry of 1. Clear? Clear till fourth point, till fourth column. Now we are moving on to the fifth column. Now we have in the first column, three values, 0 plus 0 plus 1. That's very simple. You will simply get the answer 1. And then in the next sixth column is 1 plus 0. The answer is 1. Seventh column is going to be 0 plus 1. The answer is 1. And the last bit or the last column is 0 plus 0, and you get the answer of 0. So in this manner, this is your sum value. Any questions? This is only done to make you comprehend how to work column wise. Remember, always start from this point. Remember two things. First thing is start from the right hand side. That will be your first column, column number 1, and move ahead. And for that, you need to refer to the principles that we have learned just recently. Are you clear? Are we clear about it? Yes. Maybe move ahead. Now is the question. There are two activities which I want you to do very quickly within 2 minutes. The first question. It should not take more than 2 minutes. Or chalo, maximum 3 minutes. Not more than 3 minutes. I hope that we are done with first question. And I'm just sharing the answer. You can see, is your answer the same as is mentioned? You can go for the self-correction. See, it's so simple. What you do is you are going to start from this side. Again, you can see 000, 11101, and add 0, 11, 00, 110. You're going to start from this position. 1 plus 0 is a 1. 0 plus 1 is a 1. 1 plus 1 is going to be 0 with a carry of 1. And then 1 plus 0 plus 1 will be 0 with a carry of 1. Then 1 plus 0 plus 1 is going to be 0 with a carry of 1. Then 1 plus 1 plus 0 will be 0 with a carry of 1. 1 plus 1 plus 0 will be 0 with a carry of 1. And 1 plus 0 plus 0 will be a 1 here. So this is your answer for question number 1. I hope that all of us have got the same answer, isn't it? Yes or no? Okay, that's great. Wonderful. So the ones who have got the answer, just pat your backs and be ready for the next question. Come on, be quick. If you have understood it well, it means that now you can answer the next question within maximum 2 minutes. Time starts now. Done? Okay, now it's simpler. 101 00010, add 00 111 111011. So here we can see we're going to again start from the right hand side. First column, 0 plus 1 is 1. 1 plus 1 is 0 with a carry of 1. So carried is here. 1 plus 0 is 1. 1 plus 0 is a 1. 1 plus 0 is a 1. 1 plus 1 is 0 with a carry of 1. And 1 plus 0 is 1. And 1 plus 0 is a 1. Yes, any questions, any problem regarding this topic? Regarding these two questions of addition of binary numbers? Are we all clear about it? Yes, Ali? Ahmed? Shayan? Okay, that's great. Now, if we are clear, then these are some questions which I want you to take as an assignment. Do them. I hope that you will be getting the right answers. Again, a simple tip, you can verify your answers the same way as I talked about, that you can find out the equivalent denary number for both the values and then add them, and then see that whether your answer for the binary value is matching with your answer for the denary number. And by the way, okay, now a very good question asked by Ali. If, for example, you have three numbers, what will you do? By the way, can you think of an answer? Ali has asked a question that if, for example, right till now we have worked with two values only, two binary values. In case you have three binary values, what will you do then? Okay, that's great. One option is we do the same way as we have done the denary addition, that we are going to add the three numbers. And another one can be, what we can do is we can first of all add two numbers, two binary numbers, and then the result will be added with the third binary number. That is also possible. Clear? Yes or no? Now, another question. Now you can see add 0 110 1110 with double one with 110 1111 4 times 1 and then a 0, and it has to come in 8 bits only. Just be cautious that the answer for these two binary values which are in 8 bits are going to come in 8 bits only. Now if you perform addition in the same manner as we did, you can see I'm going to start. It's going to be 0 110 1110 to be added with 110 1111 and 0. We'll start from the same point. 0 plus 0 is 0. 1 plus 1 is going to be 0 with a carry of 1. Now we have 1, 1, and 1, 3 ones. It will be 1 with a carry of 1. Then we have 1 plus 1 plus 1 will be 1 with a carry of 1. Then 1 plus 1 plus 0 will be 0 with a carry of 1. And then we have 1 plus 0 plus 1 is going to be 0 with a carry of 1. And then we have 1, 1, 1, 3 ones, 1 with a carry of 1. And then we have 1, 1, 0 will be 0 with a carry of 1. So I hope that the addition is clear to all of us. So we all have got the same answer. But this answer is a bit different from what we have seen. And the change is, you can see for yourself that now your answer is coming in the 9th bit. What will happen then? Now that's a problem, isn't it? We should not be getting the answer in 9 bits. Then how this problem is resolved? Look, you can see when we perform this addition, this has resulted in generating the 9th bit. And if I perform the same, like I told you the example that if you want to verify your answers, you can convert the binary number into its equivalent denary number and then add them, and then you will get the answer. And you can see for yourself that, by the way, if you just perform the addition of these 8 bits, which are 0, 1, 0, 0, 1, 1, 0, 0, you can see for yourself that this will give you the answer as 76, isn't it? And in reality, the answer of these two binary numbers, which are 110 and 222, 110 and 222 should be 332. So it means that the answer is actually incorrect. So you are extending the value beyond the capacity of the byte. It is no more occupying 8 bits. It is now moving on to the 9th bit. And this is causing a problem. So by the way, if you can recall, what is the maximum value that it can be stored in an 8-bit value or in an 8-bit register? If all the 8 bits of byte are turned on, what is the final answer that you obtain? If you recall, it's 255, correct. So it means that this generation of 9 bit is a clear indication that you have obtained the wrong answer. It has exceeded the capacity, it has exceeded the assigned area, assigned position. And this is known as overflow error. Be cautious about this term in case you get a question with 2 values or maybe 3 values or whichever number of values are supposed to be added, and the result is going beyond the capacity of 8 bits, it means that you are occupying the 9th bit, then it is called an overflow error. And this is indicating that your number is too big to be stored in the computer using 8 bits. I mean, it's too big. It's not coming in 8 bits. It's going beyond the 8-bit capacity. It's occupying the 9th bit. And this is called an overflow error. So be cautious. If you get such a question in the paper, you need to be very cautious. How to answer, you'll perform the addition the same way. If they ask you what happens, then you will be mentioning the error name is as overflow error. And you'll be talking about that overflow error is because that you are getting the result of 2 binary values. The addition of 2 binary values is resulting in the 9th bit occupation as well, which is the clear violation, and that is why there's called an overflow error. I hope that we all are clear about it. Any questions? Any ambiguity? Yes, children, are you all clear? Overflow error is clear? Yes, that's great. If you have understood this well, that's wonderful. Jazakallahu khairan kasira. Thanks for watching my video, and keep on liking my videos, keep on subscribing my channel, and please share it with your friends and family. The next video will be inshallah regarding the logical binary shift. So keep on promoting my channel, keep on promoting my videos. Allah Hafiz.